Great everyone, now I will talk about my work whose title is Post-Process of Titanium Microparts through Electrochemical and Chemical Polishing. The actor of this work are me, Ana Rodrigues, Santiago Caragaia, and the professors Fábio Xavier and Júlio Cordioli. The summary of this work are the introduction, materials and methods, results, lace machine component characterization, electrochemical polishing, chemical polishing, conclusions, and then the reference. So start with the introduction. First talk about the lace machine. That is a thermal remove process which the material is removed, and sometimes this process can result in a rugged surface and a rematted layer. For remove these characters from the surface, polishing process like electrochemical and chemical polishes can be used. The electrochemical, it consists in submerge the workpiece with an electrode into an electrolyte, and so the removal of material takes place. The chemical polishing, it consists in submerge a workpiece in a corrosive solution and the removal of material occurs. The workpiece on the stir is a titanium clamp that is used to attach hearing aids and cochlear implants in the middle ear for case of moderate to severe hearing loss. The aim of this work is to characterize the surface quality of lace machine components before and after polishing, and the electrochemical and chemical polishing was used in order to remove the burrs and the removed layers. So the materials and methods. The material on stir is a titanium grade tube, and the geometry is shown in the figure 1 and has 4 mm of length, 2 mm of width, and 0.1 mm of thickness. The workpiece was cut by a Varlace LS3000 machine, and the configuration are these shown here. For the electrochemical polishing, the electrode was a sulfuric acid and the electrode a piece of stainless steel. And here we have the other configuration, and the time was 5:15 and 3 minutes. For the chemical polish, the solution was a sulfuric acid 8F and nitric acid 8NO3, and the proportion was 30 ml of 8F and 70 ml of 8NO3. 2 concentrations of solution was used, the first with 100% of concentration and the second with 15% of the first solution plus 50% of distilled water. And the results. First, I will talk about the result from the lace machine component, characterization, and the result of analysis of optical microscope and scan electron microscope. The same are present in this section. First, in the figure 3, we have the picture with magnification of 15 times from the bottom in A and the top in B of the clamp, obtained by the optical microscope. And in this figure, we can see some defects from the lace curing process, like the oxidation, the incomplete curing, burrs, and rematted layer. Here in the figure 4, we have the bottom of the clamp with magnification of 200 times in A, and we can see some oxidation and some burrs. And in B, we have the top of the clamp with 100 times of magnification, and in this region we can see that the dimensions are reduced compared with state A, and the oxidation and the burrs are more accentuated. In the figure 5, we have the image obtained by the SEM with a magnification of 1000 times in A and 3000 times in B, and we can see some defects. First, in the appearance of cone, because the bottom edge is bigger than the top edge, and we can see some ondulation and burrs and remelted layer. And in this section, we present the result from the electrochemical polishing, and here in the figure 6, we can see a surface unpolished in A and the surface electrochemical polishing for 5 minutes, and we can see that the oxidation it disappeared, but the burrs is still present. In the figure 7, we have the result from the electrochemical polishing for time of 50 minutes in A and 23 minutes in B, and in A we have the presence of a corrosion in the tree format, and in B we have a surface burr. Both then can remove the burrs from the surface, and in this section we will present the results from the chemical polishing. In the figure 8, we have the surface before and after the chemical polishing for concentration of 100% in the bore region, and we can see that the burrs and the oxidation are reduced, but the surface become porous, and we can see that the dimensions are reduced, and that was high in the top of the clamp, and the reduction in the remelted layer. So here we have the result from the surface chemical polish for 50% of solution, and doing a comparison for both solutions, we have the first that the reduction of the dimensions and that was bigger for the top of the clamp, and we have the reduction in the burr oxidation and the remelted layer. For the second, we have the same result, but both regions reduce the dimension and close passage. Here we have the conclusion of this work, and the surface quality was evaluated. The electrochemical polishing can eliminate the burrs and the remelted layer, but the surface suffers damage, and the chemical polish can reduce the burrs and remelted the layer, but result in a porous surface and a geometry reduction. Both were able to improve the surface quality, and the manufacturer vote is promising for full importable hearing device fabrication. Here are the references, and we are grateful for FNAP full support to research, and thank you all.